To summarize, in our previous session, we have introduced two systems, PSTN and PLMN. We have introduced to these two systems completely. And then I have introduced myself, and that's the thing that we have done in our previous session. So, what is today's agenda? We are going to today introduce ISDN, PDN, and GSM. We are going to introduce these things. And then also at the end of the training, I'll be introducing some of the course content. Um, and then we continue into the next class further. That's what we do. All right. So far what we have introduced, we'll try to repeat that in a minute. So we have a mobile station which would like to get its services from something called as a mobile switching center, which is typically a database plus a software plus call exchanging mechanism available here. With its capabilities, it will be able to establish the calls with the other mobile phones. But the connectivity between the mobile station and MSC is not completely wired connectivity, as we are expecting the mobile station to move around without having any wired connectivity. We introduce the radio concept here. So what happens? Whatever the information that the mobile would like to send to MSC, mobile is supposed to send it to a tower which is named as PTS. Uh, and then that information goes to another central component called as BSC. And what does this BSC do is it is taking care of radio resource allocations for all the mobiles that are present under all the BTSs. Yesterday, almost at the end, I have explained this concept. Actually, this radio resource allocation, we cannot allocate radio resources permanently to any mobile. We have to allocate the radio resources to these mobiles only when they need it. So somebody need to keep allocating the radio resources and taking it back. But we could give that functionality to BTS. We can definitely do that and give this functionality to BTS. But to implement that kind of a complex software and hardware capabilities required for radio allocations, um, they needed to invest a lot of money. So into every tower, into every BTS, they thought that instead of centralizing it at one place, it will be better if we instead of distributing it into every place, we can easily centralize it into one place called as a BSC, which is going to be a complex hardware and software, and which is going to take care on radio resource allocations for all the mobiles in under all the BTSs. And then once the BSC allocates the radio resources to the mobile users, and once the by using that radio resources, once the mobile sends the information to BSC, BSC forwards that to MSC. Ultimately, uh, this is a two-way segregation. The radio related tasks will be completely handled between BTS and BSC. Whereas on the other hand, only service related tasks will be handled by MSC. Like when the mobile is trying to initiate any kind of a service, trying to make a outgoing call or trying to send a SMS or trying to initiate any kind of a GSM based service, then this MSC will come into play. Otherwise, MSC won't come into play. MSC need not to come into play. Otherwise. So that's the basic idea. There is a segregation. Radio resource related things will be dealt by these guys. MSC is going to deal with these guys' service requests. Okay. So far we have learned up till here. But what else we need to introduce? Is this the GSM entire network architecture? Answer is no. This is not the network architecture, so there is more to it. So what is more to it? So they started adding many more such BTSs to cover many more cells, the areas that covered by these towers, which we typically be calling it as cells. And there could be multiple BTSs that are organized by BSC. Multiple doesn't mean two. It could be any number. Like it could be 20, it could be 80, it could be 100, or 500. It could be 1,000 also, depending on the kind of BSC the operators are buying and installing it, and what is the capacity of the BSC, and how many BTSs the BSC can serve based on its hardware and software capabilities. So it has got nothing to no numbers are fixed here. Everything is related to software and hardware capabilities. If you buy a bigger hardware and bigger software, you will be able to serve more and more BTSs and more users. If you buy a lesser capacity one, you will be able to serve lesser number of users and less area. It is always like that. Now, we thought MSC will have a database, your mobile switching center, which is also basically a switching center or exchange, mobile related exchange, which obviously will have a database. Now they started giving names to each and every entity here. So they have given a name here to this component called as VLR to that particular database. They allocated a name. There is no wrong in just giving a name to a specialized entity. It's okay. But we can easily imagine what kind of information that will be present in this VLR. All the subscribers who typically roam around this MSC geographical area. So all that details will be present under this VLR. Storage will be there in the VLR, so that if any of those mobile phone users, if they try to initiate the services, that service request will eventually go down all the way up to MSC. MSC, with the help of the information stored in the database, it will be able to make a decision whether to accept that service or not. It will be making such decisions, your mobile switching center. So it's a service component, as we have learned earlier yesterday's session. It is it is making service decisions. Uh, but one MSC need not to serve a single BSC, whereas one MSC can even serve multiple BSCs as well. So again, how many BSCs one MSC can serve? And that meaning is how many users requests can be received by MSC and processed by MSC. Again, that would be dependent on MSC's hardware and software capabilities. There are different telecom equipment manufacturing companies present in the world, and each company will be making five or six different flavors of MSCs, and every MSC will be operating at a different load level. So operator, for his customer base and how many customers he expects in his geographical area, what sized MSC he need to purchase and place it there, operator will be able to decide that on the basis of his customer base. So again, all these numbers are nothing is fixed. Uh, so how many cells will be present in a BTS is can vary. How many BTSs will be present under a BSC can vary. How many BSCs can be present under one MSC? It can vary. It all depends on each component's hardware and software capabilities. There is no fixed number in any network anywhere in the world. No fixed number, nothing. It's all variable. So now what is this capability of this MSC is, let us suppose that um, the MSC's capacity is like store 1 lakh users subscription information, 1 lakh subscribers details, MSC can store in its VLR, in its database. Let us take that as an, um, you know, just an example. Now, uh, if the operator starts to do some kind of a campaign in a particular geographical area, operator finds out that, hey, in this area, so far I have 1 lakh users. Now, all the cells that are spanning into that geographical area, all those cells under the BTSS, those BTSS under BSCs will fall into this MSC, and this MSC will be able to take care, because MSC is having the capacity to store 1 lakh users information in its database and deal with 1 lakh user services whenever initiated. And MSC is happy to serve those 1 lakh users. Says that, okay, well, good, no problem. 1 lakh users I can deal. But the moment the number of customers started like increasing, it's more than 1 lakh users. Now MSC starts facing the problem. Hey, if the customers started increasing, what should operator should be doing? He must be like removing some of the cells, maybe some of the BTSS, maybe some of the BSCs from this MSC's jurisdiction, because the number of users in that area are more and more. MSC has got a capacity limitation to store how many users and deal with how many users. There is a capacity restriction present on that MSC. So operator will think, hey, we have to discard some of the users from these MSC operations. Okay, we will discard some of the users from this MSC operation because we have already reached a saturation point for this MSC. Well and good. But what do we do with those users? What do we do with the remaining geographical area, remaining cells and remaining BTSS and remaining BSCs? What do we do with the remaining areas? So then the problem starts once again. So that leads to this second thing. What is the second thing? So in another geographical area where another 1 lakh users are present, you need to place one more MSC, and you need to have some more BTSS and PSCs placed to help serving the users present in those areas. You have to do this because there is no MSC in the world which is having infinite capacity to serve any number of users. That's not possible. Maybe if you take a very small country with a big area, you can actually deal with a single MSC itself. You don't need many MSCs because all the users' information could get stored into maybe that's one single MSC VLR into one database, because that is a small, that is a country with very small population. That is enough. You don't need a second MSC at all. But that won't be the case always. So the capacities will keep varying country to country, place to place. If you take a country like India, where huge population, huge number of users, you cannot have a MSC with 1 lakh users capability sufficient for the entire country. Not sufficient for the entire country. Not even sufficient for a district. If we take the reality, if we take the capacity as 1 lakh, of course MSC capacities can be much bigger. I'm just taking it as an example so that you can get an idea there, that's all. But ultimately you end up having multiple MSCs. But the biggest problem when we have multiple MSCs is the users database will get distributed into these two MSCs. That means if 2 lakh customers are there for the operator, we have to store 1 lakh customers data into one MSC. We have to store another 1 lakh customers data into another MSC. Okay, we do it. There are two MSCs which are storing 1 lakh subscribers, 1 lakh subscribers data into each of their databases. Very well, no problem. Good, nice. Now, where the problem starts? These 1 lakh buggers who is present under one MSC, they will never stay there in that MSC always. They wanted to roam around. Same case with the other MSC users as well. They won't stay as it is. They even wanted to move from place to place. So obviously, even though you have stored, if you decide to store 1 lakh subscriber data permanently in one MSC, another 1 lakh subscriber data permanently in another MSC, as long as the users are sticking to their ground, sticking to their geographical location, everything holds good. Everything works perfectly, no problem. But the moment they started roaming, moving from one place to the other place, one of the user who is supposed to be under this MSC's geographical location, once he started coming into some other location, when he sends any kind of a service request, obviously these BSCs and BTSs and BSC are actually having the physical connectivities. They are going to blindly forward those service requests to this MSC. Obviously, they don't have a choice because they don't have multiple connections existing with multiple MSCs. These BSCs are divided according to their geographical locations. So the moment any service request generated from a roaming user, these BSC and BTS and BSC will forward it to this MSC. When this MSC goes and checks in his VLR, the database called as VLR, database will show him empty hand. He says that, hey, who is this bugger, man? Hey, we never know this guy. I think this guy's information is not present in our database. I think we won't be able to deal with this fellow. Who is this fellow? I don't know. We never seen him before. Because this MSC is having his own customer base, 1 lakh users. Okay, then they started seeing a problem. In the picture, I could only stuff two MSCs, but in reality, there could be hundreds of MSCs all over the world. Um, Across different countries, different locations, you can have hundreds and thousands of MSCs storing the subscriber data, um, segregated subscriber data. But when they do that, they started seeing the problem that what happens when the users go into roaming from one area to other area. Then they thought that this should not be the actual solution. This is not working out. We have to deal with this problem in one more way. So what is that one more way? What did they do? So they eventually derived one more database called as HLR, who is going to simply store all the subscriber data of the operator. Any operator will have this kind of a HLR, another database, where all the subscriber information gets stored, belongs to that operator. Now, what is the specialty of HLR? HLR never makes any service-based decisions. It will be storing subscriber details. What is the subscriber number? What kind of services he subscribed, whether he is having STD calls or not, SMS outgoing capability is there or not. Like that, it will be maintaining all the subscriber details, this HLR. Then the problem comes into our brain. It says, question is, why are we maintaining subscriber data at two places? One is at MSC VLR and the other one is at HLR. So they thought that, hey, even though we are going to maintain the subscriber database at two places, the second place, which is the MSC VLR, that database is going to be a temporary database. It will only store the information of the users as long as the user is present under that network, under that particular geographical location. That means who is the permanent subscriber information storage component? That is your HLR. That is the permanent subscriber storage component. It will have the subscriber information 24 by 7, 365 days. It will have the subscriber information. So what does he do with the subscriber information? Does he make any decision to accept any service from any user? Never. It never directly deals with the user at all. Nothing. Then what does he do? These GSM mobile phones, whenever they wanted to request the services from their nearby MSC, their geographical MSC, they have put a condition to this mobile. They have told the mobile that, hey, before you start begging for your services from your MSC, nearby MSC, you are supposed to perform something called as a registration. You have to go and speak to this MSC and perform registration. Okay, mobile started accepting that. Yes, we are okay with it. We will do this registration, whatever it is, no problem. So then they have put some kind of a software into this MSC and told the MSC that, hey man, if any mobile wanted to register with you to get the to request for the services, you immediately go and bring that guy's subscriber details from the HLR. You won't be having MSC directly won't never will be having the subscriber details. Who will be having the subscriber details always is your HLR. So MSC, whenever a user is supposed to do a registration with him to request for the services, MSC is supposed to visit the HLR and bring that subscriber information. Why do we require that subscriber information? Why are we procuring it from HLR? What is the need? Because whatever the calls that the mobile is initiating or whatever the services the mobile is initiating, those service requests will go to this MSC. So who need to make the decisions on these services? Who need to take a decision on this service? It is the MSC who need to take a decision on this service, whether the service must be accepted or rejected. So MSC must know complete subscriber profile, what kind of services this guy subscribed. Everything MSC must be aware. But because we did not, the operator is not directly storing the details into MSC VLR, operator is directly storing the details into HLR. The subscriber information is stored into HLR, only one permanent database. So whenever any user try to register with the MSC VLR, these guys will quickly go and consult the HLR, bring that subscriber information and keep it with them as a copy. So what do they do with that copy? As long as the user continued in that particular location, this MSC and VLR will be making the decisions with the help of that subscriber information. They would be making the decisions about they would be making the decisions on uh, these things, basically the call requests or any service request that the user makes. Okay, so what happens now? What happens? The user shifts to another location. The user moves to a different geographical location. Um, Obviously, the mobile is now supposed to be registered with this MSC. So when the sorry, so when the user attempts their when the user attempts that registration with that new MSC will look into its database and find out the user's details are not available. Obviously not. So what does this MSC VLR would do? This MSC VLR would immediately contact the HLR and they explain the HLR that, hey, one of the guy is coming into my network and try to do the registration with me, and he may be asking for services in the future, near future. So I would like to have his information. I would like to know what he is, who he is, and what kind of services he is subscribed to. I need these details. This MSC and VLR go and question this HLR. So this HLR immediately what does he do is provide that subscriber information to this MSC VLR, and it goes and tells this MSC VLR that, hey man, The user is now not present in your location. He now moved into a new location. uh, so a new MSc VLR contacted me for the subscriber details. I provided the details to that MSc VLR. You don't need to take care about this mobile user anymore. He is not going to request any services from you. Now you can rub off his information, whatever you have in it in your database. Please remove the details. You don't need it for time being. If the user comes back into your network, that time you can come back and ask me. But till that time, you can remove you can remove the subscriber information from your database, and the details are now available with this guy. And whatever the service request the mobile is making, those service requests will be reaching this MSc, and this MSc will be making the decisions on the basis of the information stored in this database. Will be making the decisions. So what kind of a database they have made this MSc VLR? Instead of dividing the subscriber data and storing it into different MSc VLRs, they have made the MSc VLR store only the subscribers who are under their location at that particular moment in time. That means the MSc VLR's database would be completely getting changed. It keep on getting changed when the subscribers keep moving from different locations into this MSc area. Some subscribers information gets added. Some subscribers leave the area, go into other locations. Some subscriber data will get deleted. Why MSCs allow to delete the data? What is the purpose of deletion? Of course, they are going and getting the data from HLR, it's fine. But why do they have to delete it? If you don't delete the users who are not in your area, your database size will keep getting increased. After some time, it will become unmanageable. Or if you want to search that big database, it will take more time for you than a small database. So if you have always a small database, a compact database, the things will become faster. The situation will become faster. You will be able to search faster. You will be able to find out that subscriber information faster. You will be able to make up the decisions faster. Simple. You just imagine in your brain, if your computer is overloaded, like if it is 500 GB, you have almost stored near to 500 GB into your hard disk. When you try to open any drive, it seems to take more and more time because it need to read lot of information from its, the memory chunks. So it will be taking more time for reading the even primary chunk details and display it to you. Same thing here also. So MSCs would like to have their database to be maintained in a very compact manner. They don't want to permanently store the information because they also know that their users won't be staying in that location permanently. Of course, some users may never move from that location. Some users will permanently stay there. For example, there could be one guy who might be present in a village. He might not even go out of that village in his entire life. He may be there at the same place. Even if he moves 3 or 4 villages outside, and he will come back quickly. He is still under that MSc. In his lifetime, he'll never needed to move to anywhere. So that case, subscriber details will definitely get stored into only that MSc VLR. No other MSc VLR in the world needs that subscriber details because the subscriber is never moving. He is going to be there forever. So what was this when you compare it with your old telephone exchange mechanism? Your telephone exchange is also a switch, a exchange, just like your MSc, who is making the subscriber decisions. So the switch is the exchange, and the switch is the one who is making the decisions. Either it is your landline situation or either it is your mobile phone situation. Doesn't matter, but it is the same case in either of these two scenarios. But what is the difference between the landline part and here? A landline phone is permanently connected to a nearby exchange, and it never moves because your house never moves, your landline never moves. So obviously it will be permanent. So they have to store the information into that nearby landline phone exchange permanently to make the decisions. You never need to shift that information from one exchange to another exchange. Not required, because it's a permanent uh, position for the devices. But not the case here. Here the users are moving. They may move from one area to another area. So you have to keep shifting the subscriber database of one user from one MSC to another MSC, because MSCs are the ones who need to make service decisions. So that is how they have devised these multiple uh, database plan. Instead of having one permanent database, they have brought in, one permanent database and multiple temporary databases with multiple switches or multiple exchanges. So when the users kept moving, this database information also will be moving between these exchanges. So if you take Airtel Hyderabad, for example, if you take that Airtel MSC present in Hyderabad, now Airtel MSC in Hyderabad would contain like 90 to 95% of the users from Hyderabad locality itself. But the remaining 5% of the people are coming from different locations all over the world, maybe from different other states, different other countries. There might be a lot of people in Hyderabad who are from different places. Now, when they first arrive here, what does Hyderabad MSC do? By looking at their number, Hyderabad MSC will be able to determine, oh, this particular number belongs to so and so location. I need to contact that particular location's HLR, and I need to gather subscriber information from that HLR. So there could be some person who is visiting Hyderabad from Paris. So now this actual subscriber was a guy who lives in Paris. So his information permanently gets stored in a Paris HLR. So what does Hyderabad MSC do? When this guy arrives for the first time, try to do the registration. Your MSC, with the help of the numbers that are quoted by the mobile phone, MSC determines that this guy is a Paris user. Now Hyderabad MSC try to contact Paris HLR, gather the subscription information from there, ask the HLR that, hey, is this guy your network user? Can I provide the roaming services for him? If I provide the roaming services, what should be the billing I should do? What kind of a billing I should do? Like these kind of details you can ask from the corresponding HLR, where that subscriber belongs to, where that user belongs to. So there could be a lot of HLRs in the world, lot of operators, a lot of HLRs in the world maintaining lot of different subscribers information. But you will be able to understand to contact which HLR on the basis of the number that the mobile user is having. So they will keep all the logic into that mobile number. What is that numbers and all that we learn later. We call it as IMSIs, International Mobile Subscriber Identities. So with the help of those numbers, you can determine from which HLR you can extract this user's subscriber details. You can determine that, and you will go and fetch that information from that particular permanent database. Okay, so when you do a blind comparison now between this network we are seeing here and your landline network subscriber information is permanently stored, and there is a direct cable connectivity from the device to the exchange. But in case of telecom network, the data is fetched by the local exchange temporarily, but to reach your local exchange also, there is no direct wired connectivity. Instead of wired connectivity, we are managing the connection between mobile and the exchange, or mobile and the switch, with the help of radio components who are taking care of radio resource allocations in the network, called as BSC and BTS. So we are replacing that single piece of a wire that we are having between landline phone and landline exchange. When it comes to the telecom network, From mobile station to the switch, we are having a radio connectivity between mobile station to BTS, BTS to BSC, there is a wire, BSC to MSC, there is a wire. With the help of this, we are replacing it. But ultimately, whether mobile can reach your switch or not, that is the only thing that matters. Whether the mobile can reach that exchange, that is the only thing that matters. Yes, mobile can reach that exchange. At the time of reaching the exchange, is the information available with the exchange to make a decision related to this user? Maybe, may not be. If the information is available, your MSC VLR make the decision immediately. Whatever the service mobile is requesting. If the information is not available, MSC and VLR will try to fetch that information from the permanent database called as HLR. That's the whole idea change. So to deal with the roaming users, because we are giving the users the freedom to move from one location to another location, they are bound to move. So to help the moving users, we need to move the database also from one switch to another switch, which was not the case in your landline phones. That was the biggest change between the landline system and your telecom system, the user subscription information movement from one place to other place. So these are the major components that we see in GSM, but they ended up introducing some more components for serving some other requirements. For example, we have another component, another database here called as authentication center, which is performing some authentication related special activities. What is the meaning of authentication? Let's think about it for a minute. What is this authentication center? What does it do? Let us take a landline phone case. So there is a wire connected from landline exchange to your home. So you can make the calls by using your phone. So you have made the calls in the first month, everything good. Second month, everything good. Third month, when you got your phone bill, you have seen some extra numbers, you extra calls. So your bill got increased. Now you have got you got suspicious and say, hey, who is making these calls? So you gather all the people around in your household and ask, did any one of you made these calls? And everybody says, no, we did not. Now you can't tell this situation to the people in the exchange. We are not making these calls. So what the typical landline phone exchange operators will suspect is, I think somebody might have cut the wire that is leading from your house to the exchange in the middle. They might have joined it with a T jointer, and they might have connected the other joint to their device, and they are making the calls from there while you are not using your device. So they are actually making the calls because the call is getting initiated on the wire that is leading to your house. Bill is against your head. You have to pay it now. Now, how to solve this bloody issue? If somebody is cutting the wire in the middle in the night, 2 o'clock, and making a call, you cannot keep a 24 by 7 surveillance all the way from your house to exchange, because the wire can be cut anywhere. If the other person is expertise, the hacker who is expertise, so he can cut the wire anywhere, and he can join his device there and start making the calls. But the bill is against on you, bill is on your head. What do you do? How do you solve this issue? So they introduced a locking mechanism. They said that before you make a call, you need to specially dial a lock number. When you send that lock number to the electronic exchange will read that and unlock your device. Only after unlocking your device, your service request will be entertained. Otherwise, it won't be entertained. So I'm giving this code to you. So the exchange people have told that your code is this. Your code is 123456789. If you dial this code first, or only after you dialing this code first, along with a star or a hash, then only your phone will unlock and you can make the calls. Now, what the hacker do in the middle? Hacker will cut the wire in the middle. He try to make the calls as usual, but his attempts will fail, because whenever he try to attempt to make a call, the exchange won't accept the services because the device was not unlocked, as the hacker did not put the code in. Okay, so that is an best approach. So can we do similar to that in our radio? Why do we have to do similar to that activity in our radio operations? What is the need? Because anybody can manufacture a SIM card, because SIM card manufacturing technology is not rocket science. Anybody can manufacture duplicate SIM cards, and if you put the duplicate SIM card into any device, that guy can start making the calls. So when the call goes to the MSC tries to verify your just look at your number, and he accepts your call by looking into the subscriber information, and the bill will be against your head because that is your number. So somebody faked a SIM card which is actually like using your number. And when you quote, when that other hacker user, when he is making the calls, but the bill will be against your head because that is your proper number. So authenticating a user before accepting his services makes sense, even in wireless communications, because at least in the landline phone case there is a wire. At least if the wire is going through maybe in the underground, it will be impossible to cut it. But when it comes to the radio, it is not a big deal. If you want, all you just need is a SIM card. If you can manufacture a duplicate SIM card which you can push the subscriber information into it, and that's all. If you put that duplicate SIM card, you can make the calls on behalf of somebody else. So we wanted to avoid these kind of activities by the hackers and third party attackers. So we require some kind of authentication mechanism to verify the users are genuine or not. So all that authentication mechanism is going to be dealt by this database called as authentication center. How it does the task, how it will be able to generate the information required for authenticating the users, we'll find out in the coming up slides. We'll see that. There is a question. How data is transferred from one VLR to other VLR? Okay. Data will never get transferred from one VLR to another VLR. Never, ever. Just remember the sequence cleanly. When the user is here, this guy when try to register with this MSC VLR, this guy goes and talks to HLR and get the subscriber data. Job finished. When the user moved into a different location, when he tried to register with this MSC VLR, this MSC VLR detect that that guy's information is not available. MSC VLR goes and talks to HLR, gather the information from the HLR. When HLR forwarding the information to this MSC VLR, that time HLR goes back to this MSC VLR and tells him that, hey, that user is no more with you, remove the information. So the information is not moving from one MSC VLR to another MSC VLR. The information is always going from HLR. Here the permanent database is HLR. How do the MSCs detect which HLR can give the information to them? How they will detect it? They will detect it with the help of the number that you have quoted. Depending on the number that you tell to your MSC, this is my number, so and so number. So depending on that, MSC will determine that this user belongs to so and so HLR. I will go and gather the details from the HLR. You will never gather it from other MSC. Other MSC will never provide you that information. Belongs to one user. Okay, fine. There is another database we have here called as EIR, stands for Equipment Identity Register. The purpose of this is to maintain or store information related to your mobile phone related numbers. So to prove whether your mobile phones are genuine or not. So there could be a SIM card genuine or not. There could be a mobile phone genuine or not. When you are traveling on a bus, somebody picked up your mobile phone and they go home. The guy who is pickpocketer, he will remove the your SIM card and throw it out. He'll put his SIM card in it and start using the phone. But when you give a police complaint and when the police complaint is forwarded to the corresponding operator, the operator will put that mobile device, your based on your IMEI number, something called as your mobile's IMEI number. That mobile device would be kept into blacklist in the EAR, represents as stolen. So when anybody try to use that mobile device and try to use it for his services, this EIR will recognize this and will report it to MSC that, hey, this particular user is trying to use a stolen mobile phone. We should not accept the services. We should reject the services. That's the basic idea here. So another database. Now the question comes into our head is, why do we need these many databases? Why can't we combine all these databases and put it into one big single database? Why can't they do it? There are some implementation issues to reduce the cost and to have some issues solved. At the time when they have implemented this network, they thought that it would be better if you store each of these details into a separate database. It will help us implement the network in a better way. So they identified that after doing some experiments. So if when they bring up any big network in the world, they will do lot of experiments. They will do lot of trial and errors. So when they have done the trial and errors, they found out that if you maintain a separate database for each one of these things, it will be much better instead of storing them all together in one single box. So that's why these many small databases start popping out. Each one is doing its own functionality. EIR is verifying the mobile phones, authentication center is verifying the SIM cards, HLR is storing the subscriber related information, and who is making the service decisions is your MSC with the help of the information stored in the VLR. Of course, that information is gathered from HLR. And then what we have? We required one more component called a GMSC, gateway MSC, when you have to lead the calls out of this network into the external networks. That means if you consider these two MFCs are part of one operator's network, and if you are trying to make a call from that operator network to another operator network, for example, from Airtel to Idea. Okay, so what do we need to do? We have to route the calls from Airtel network into Idea network. We must do that. So whenever we are sending those calls out or bringing the calls from the external network, when we are bringing in, this GMSC will come into play. Stands for Gateway MSC, or also called as a gateway switch. As the name itself suggests, gateway suggests, it is leading you to the external networks. That is the meaning of gateway for you. So this GMSC is actually going to integrate with all these components in the best possible connectivity order. They have connected them this way. How this connection will make sense? Why it is only connected this way? uh, there are a lot of experiments done, and they found out that this would be the typical thing that we can implement. For example, this helps us. How it helps us? If an incoming call arrives from the some other external network, an incoming call arriving into GMSC,
Now this GMSC have to send that incoming call detail to one of these two MSCs, either this MSC or this MSC. But GMSC don't know whether the subscriber is present under this MSC area or this MSC area. GMSC don't have any idea on that. So what does GMSC do? GMSC consults HLR and ask him that, hey HLR, can you please tell me mobile is under which MSC VLR? You might have noted down the information on which was the last MSC VLR took this particular subscriber data. You might have maintaining that information. You might be maintaining the details. I am sure that you have that information. To whom you have given the details last, to which MSC VLR you gave the details last. You are maintaining that. I'm damn sure about it. So please tell me, mobile is right now under which MSC VLR? Under which MSC VLR's jurisdiction? I wanted to know. So once HLR comes back and tells GMSC that the user is under so and so MSC, when HLR tells him, then GMSC can forward that call to only that MSC instead of spreading into like all the MSCs possible in under that MSC area. You don't need to send it everywhere. You have to send it to only that exactly that MSC where the mobile user is under right now. So for that reason, so they said that so this way of connecting would make sense. Of course, MSCs also directly or indirectly they can go and talk to HLR. MSCs can go and talk to your authentication center. Your MSC VLR can go and talk to AR. That doesn't mean that they don't have the technical connectivity. The technical connectivity is there. Typically this is represented like this, how it always says that GMSC is the one who will be like integrating all the databases of a network and keeping it together. Meaning is how many our MSCs are there under the one GMSC and under one GMSC? All that subscriber details would be typically present under this HLR authentication center and EAR. It is the typical thing that we can understand. Ultimately, of course, as long as the users are this particular operator users. But ignoring the connectivity, but if you actually study this GMSC's tasks, connectivity is not so much important. Those are not physical connections. Those are all logical connections, which we never discuss also because we never study GSM more than this much. We get into UMTS and LTE as fast as we can because the ultimate goal is those two technologies, the LTE for us. Maximum 3 4 classes we'll study this, that's it, not more than that. So GMSC is very much required for taking the calls outside our network or bringing the calls into our network, taking the calls out and bringing the calls in. So from anywhere in the world. Now what is that typically called as? That is typically called as this. So there is a big story behind it. Okay, so this GMSC is actually connected to something called as ISDN, and then we have PDN, PSTN, and PLMN. What are these things? And what is that middle ISDN in the middle? So they're all basics, guys, but these are very much required for you to understand the overall network architecture in telecommunications. From these basics only, we can learn the deeper subject. So what is this ISDN and what are the other three subsystems that are present here called as PLMN, PSTN and PDN? Okay, we'll see one by one. PSTN, the landline phone network that we have introduced yesterday, the international, national, that all things, that is this PSTN. PLMN, public land mobile network, which is nothing but a network which is looking like this, may belong to the different operators. So different operators, PLMNs. your telecom networks, your mobile wireless networks are called as PLMNs. Okay, and we have IPDN, packet data network. What is this PDN? How this PDN comes here and what role it plays? We will see. But first, we will try to understand what this ISDN is and what this GMSC, why it is sending the information into this thing called as ISDN instead of directly sending it into PSDN and PLMN. The calls for why call forwarding is happening through this ISDN. What is this ISDN? We never heard of ISDN earlier. So what is this ISDN? It expands to Integrated Services Digital Network. This ISDN expands to when you take that shortcut and expand it. What we get is that. Okay, fine. Name is okay. But what does it even mean? What does it do? Why do we require that? Why can't we send the call directly from the GMSC to another PSTN or PLMN? What is this ISDN doing here? What is its duties? We'll think about that in a minute. If you take the worldwide network architecture evolutions, the first network that is evolved is your landline network. So when the landline network get evolved, they started giving some kind of a numbering to each and every landline phone. So they followed their own numbering. Some random numbers they started using, and somehow they fixed some numbers and they started using those numbers. But ultimately, every device in the world is having a number. Every landline phone device in the world is having a number. Fine, good. So you can make the calls from one landline phone to another landline phone. Fine. Parallelly, other systems started evolving, which is called as a PLMN. So the people who are developing this PLMN, they started using their own number system. They started using their own numbers. They are not following any kind of a sequence. They are following their own sequence numbering, 10-digit number or 11-digit number, whatever. They are following their own sequence. Then, once these two systems are parallelly developed and they started moving forward, they started having problems. What kind of a problem they encountered? The first thing they wanted to have is have these two systems integrated together. They wanted to have that. Both the systems must be together. Now, if you wanted to integrate two systems, the biggest uh, problem is their number systems. You have to make sure that the numbers in both the systems are unique. Whatever number that you find in one system for a landline phone, you cannot have the same number present in for a mobile phone if you want to bring them together. Why? Why the numbers must be different? Why can't it be same? If the numbers are same, if you bring these two systems together, if somebody is making a call from one landline phone to another landline phone, but the systems will be confused. Hey, this number this guy is dialing is actually pointing out to a landline phone as well as pointing out to a mobile phone as well. To which network I have to route this call? To a mobile phone I should route it, or to landline phone I should route it? So the biggest problem they saw in integrating the networks is the numbering system, what numbers they were using to represent each and every device in the world. So what is this ISDN then? So this ISDN is a standard that they brought up. The people who are developing this ISDN technology, the specification bodies basically, they said that, hey, we will come up with a number system in such a way that it will never conflict the numbers, and we can have unique numbers for both landline phones and as well as your mobile phones. But these ISDN people put only one rule: any system can be integrated with ISDN, and you can actually make a call to any of the devices that the ISDN is already connected to. You can make a call to any of the devices, but the only condition is you must follow ISDN numbering rules. So whatever the number rules that the ISDN have made, you must follow those number rules. Only then it is allowed to be integrated into the ISDN network. So first they have integrated the worldwide PLMN and PSTN networks into this together with the help of this the ISDN numbering scheme by allocating ISDN numbers everywhere to every device, to your landline phones as well as to your mobile phones. None of the devices will have the same number repeated. E- Either it is a mobile phone or it is a landline phone, doesn't matter. No number will be repeated twice. The same number will never be repeated twice. Every device will have a unique number, irrespective of whether it is a mobile phone or whether it is a landline phone. That is possible with the help of this ISDN numbering mechanism that they have integrated, that they have introduced. Okay, so why the call is going into this ISDN? What is the meaning of the GMSC sending the call details to ISDN? So these ISDN number reading systems, they will be able to read the number that you have dialed, and they will be able to route the calls to either a PSTN or a PLMN network depending on the numbering scheme. Obviously, the number that you are dialing is ISDN number. ISDN number systems can understand whether this number is a PSTN number or a PLM number. Based on that, they can react and they can route the calls to the subsequent network. All good. Then what is this PDN and why it has come up? PDN actually refers to packet data network, where your computers and everything comes into that part. Packet data network, basically it is. Okay, then why PDN must be connected to ISDN? Because they wanted to get the calls even from the computers to landlines, computers to mobile phones to computers, landlines to computers, etc. So they wanted to install some kind of a software into the computer, and you allocate one number to that computer or that software present inside that computer, and that number also must be integrated with this ISDN network, and the computer will have a unique ISDN number allocated by these ISDN people, and it is integrated with the ISDN network so that you can have the calls between the computers and these PLMNs and PSTN devices as well. So the world's biggest three domains we have already is landline phone network, your mobile phone network, and your computer network, which is the PDN. So if you wanted to integrate the services, you require this. You require one common ground. That common ground is this ISDN, integrated services digital network, which is nothing but a numbering scheme. You might have heard about MSISDN, mobile subscriber ISDN. If you are coming from telecom background, you normally hear this word MSISDN. It represents your mobile station number, which is basically ISDN number. It is following ISDN standards or ISDN numbering scheme. It is following. Of course, every mobile number follows ISDN numbering scheme. It's mandatory now because we wanted to integrate all these systems and interconnect the services. If you do not interconnect the services, what will happen? You can make only a call from landline to landline. You can make calls from mobile to mobiles. You can make calls from a computer application to another computer application. You can never make inter-system calls from one technology to another technology. But we want that integration. That is this ISDN. Now, if you understand that name, you will be able to gather the details about it. It stands for Integrated Services Digital Network. It is a digital network, deals with the digits or basically works on ones and zeros, and it's a computer based digital network which is integrating services. What kind of services it is integrating? Who are providing services? PLMNs, your mobile phones are providing services. Your mobile phones system, which is built on GMSCs, MSCs, HLRs, that is one service system. Your PSTN is one service system where services are provided by landline exchanges, and all the landline devices are getting the services from PSTN. PDN is another service system where services are in your computers, on your computers or on your systems. PDN is. So what is this ISDN doing? By bringing all these guys to a common ground, by using a common numbering environment, it is bringing all the services together. Integrated services. Integrated means added, English word. Integrated services digital network. A digital network which is integrating the different services in the world. Okay. So now what happens? The call might get initiated anywhere. And it doesn't matter. For example, this guy is making a call to a guy who is present in one of the PLM network. Once the call details comes to MSC, MSC will check into VLR and find out that that user, that so and so user is not available in the in his database. So he will conclude that the call must be forwarded to GMSC. GMSC forwards it to ISDN. ISDN, based on the routing number that this guy dialed, ISDN will be able to determine and find out that the user is present in PLMN, and the call would be routed to that PLMN. What happens inside the PLMN, how the call would be routed, that details we'll see in our further sessions. But we are just looking at that much right now. So it's become easy right now for managing this whole network. So if this fellow makes another call, for example, to a different user, when the MSC finds out from his VLR, VLR tells him that yes, that user is with us. In fact, he is present under this MSC area. So the call will be routed with the help of this MSC into that other user. MSC will never forward that call to GMSC or ISDN or to the other PLM, not required, because the other user is also present under the same network. You never need to reach any other network. Or a guy from here, from this device, from this phone, he might make a call, and the call comes to MSC. MSC determines that it is a landline phone he is making a call to, sends to GMSC. GMSC will put it into ISDN. ISDN, with the help of PSDN exchanges that are constructed worldwide, national exchanges, international exchanges, and statewide exchanges, the call will be routed to the end device, wherever it is. I hope you're getting the clear idea on this and what these components are actually doing. Hope you're understanding that concept quite clearly right now. What kind of a system we have brought up here. So, what did we introduce today is we introduced something called as a GSM architecture or a GSM environment, where what are the different GSM components we can have. So that we have introduced, along with introducing something called as ISDN, PDN, and these two systems we introduced yesterday itself. Today we continued it. We continuing the development of the PLMN by introducing additional components called a GMSC, HLR, Authentication Center, and AR, along with our switch. So this part we have introduced yesterday. So these section we have introduced today. So these are all different databases to store different details, to check and verify everything that the mobile is doing from every aspect. So we have these many databases, and then GMSC, which is leading our calls into external network called as ISDN, where the calls will be distributed to the sub networks depending on who you are making the call to, or vice versa. Calls can be incoming. A landline guy can make a call, it comes to ISDN. ISDN sends it to GMSC. GMSC questions HLR. When HLR tells him where the user is, then GMSC starts forwarding the call to corresponding MSC, and from there the calls will be routed to the individual users.
Hello, sir.
Yes, Saurav.
Sir, I have a question. Just like MSc
Yeah.
contain multiple of BSc,
Hmm.
the MSc also contain multiple of MSc. Our MSc have its own GMSc individually.
We are not talking about the modern networks. Is in fact in the modern networks, most of the MSCs will contain the GMSC functionality on their own. So they have implemented that functionality in the latest MSCs. So when you are working on the present networks, you will always have this confusion that MSC will have their own GMSC or multiple MSCs put together into a GMSC. But the actual idea is simple. In the old days, like we are now not introducing today's GSM network. In today's GSM network, a lot more many components will be have come up already to introduce some new features even for GSM users. Okay, so we are not looking into today's GSM environment. We are looking into the original GSM environment that was brought in 1990s, starting of 1990. That time multiple MSCs would be connected to one GMSC. Every MSC was not having a GMSC, but because the software and hardware have become so easier nowadays, they started implementing the GMSC functionality into every MSC to make the things work out in a faster way, to make the calls happen in a really faster manner. So to reduce the workload and to do some kind of a distribution of the functionality, they have started doing that. But if we started learning all the innovations that they have done in GSM, we will lost a lot of time in learning GSM itself. We'll never be able to learn LTE or 5G. So there is no point in looking into any of those details other than just understanding their functionality. What does they meant for? What do they do? How the network is evolved? How the network changed? Even GSM network evolved a lot, changed a lot. Lot of things have been introduced, lot of things have been curbed. Various changes happened in the when you compare with this GSM architecture with the live GSM networks that the operators are having. You can see at least like a 30 to 40% difference between this network to the real networks that are operating today. Are we learning that? We are not. Okay, so we just introducing for the sake of introducing. That's it. So realize that uh, doesn't matter where the functionality present. We need to understand the functionality, where that functionality lies, whether the GMSC is going to be present separately or whether the GMSC is going to sit inside MSC itself, MSC box itself, and every MSC is having this GMSC functionality. That we don't care. What we have to understand is if there is a component called a GMSC, what exactly it does, what exactly the GMSC component does, and what kind of a role it will play, whether it is present in a separate hardware box or whether it is present in a same hardware box as MSC. We are not going into those deeper details. For example, in the if you take modern LTE network, um, this authentication center and HLR have been combined. We combining together, we call that component as HSS. Even though we call the component name as HSS, but the individual functional division is not removed. So we have inside the LTE HSS, we have HLR functionality as well as we have authentication center functionality. But because the hardware has become much complex in modern day, what they have done is they have brought these two databases together, HLR and authentication center together, and they have called it as HSS. Okay, so it doesn't matter whether it is present in a single hardware box or present in two hardware boxes. Their primary functionality is going to be remain same, irrespective of whether they are present in a single hardware box or two different hardware boxes. Just imagine it this way: if you have a computer, if you have a laptop, you can put an operating system on that laptop, like for example Windows operating system. But you thought that along with Windows operating system, you wanted to have a Linux operating system as well, so you can install that also. But when you are booting your laptop, you can choose whether the device should be working on Linux operating system or Windows operating system. So just on the same lines, having a functionality inside one hardware box is possible. You can combine multiple components together. We can do that. Okay, but we don't care what are those, all those changes that are taking place in the modern GSM network, because we are not learning GSM. I hope you understood that part.
Yeah, sir. Yeah. Okay, fine. Thank you, sir.
Any technical questions related to this part I have introduced now? If you have, ask me now. Okay. If we don't have it, I will start introducing the course content, which I am promised it in the earlier session. So we'll start looking into the course content for today. Okay. So this is LTE-IMS protocol testing course content. So how many modules we have? We have 6 modules. I'll not be introducing all the modules to you today itself. I'll be introducing in parts and pieces. First, I'll explain you the summary of these modules, like what majorly they will contain in LTE protocol testing, LTE-IMS protocol testing. First module is the wireless telecom and Jaran-Neutron basics. That is, we'll be learning the GPRS Edge Radio Access Network, UMTS Terrestrial Radio Access Network, nothing but 2G, 2.5G, and the 3G network basics. How many classes would be estimated? 5 to 6 sessions. Already we have completed 2 classes in this. Another maximum 4 or 5 sessions will be there in this first module. This part is required for understanding the call handovers from the LTE IMS network into 3G, 2G, or 2.5G or 2G networks. To understand those handovers, we need to have a clear-cut idea on how GSM, GPRS, and UMTS technologies work. What are the different components we have, and how the technology itself will work. We need to understand it. That is why we are going to spend only this much amount of sessions. So after that, we'll go into LTE and LTE advanced part. Um, in this in this GSM GPRS, so far we have completed 2 sessions and we have done with PSTN, PLMN, and PDN ISDN introduction. So yesterday we introduced PSTN, PLMN. Today we introduced PDN and ISDN. PDN is your packet data network, which is nothing but your computer network that can also be integrated with the PDN. That can also be integrated with ISDN. From tomorrow, be learning the GSM basics, GPRS, UMTS basics, etc. And we do a little hands-on um, on this first module. At the end of the first module, we before we enter into LTE, we do a little hands-on in understanding something called as tunneling mechanism. We have to do some little practical to understand the tunneling concepts by using these two tools called as GNS3 and Wireshark. Um, Today I will introduce the course content. Tomorrow, day after tomorrow, I'll be showing you all the tools that are present in each and every section. I will show you those tools one by one in the coming up classes. I can't do all the things in one session itself, so I'll be doing it in pieces. So these tools which we use for this practical, I should be showing in our next class. But we do a little practical in understanding the IP tunneling concepts by using these two tools, and then we'll move into our second module, which is LTE advanced, and your complete all the LTE protocols, everything. So we'll start introducing the LTE architecture evolution. We start learning all the LTE network elements, all LTE protocols. We introduce them and we learn them very deep. And we learn all the call procedures, log analysis, everything on all important LTE procedures end to end, including LTE advanced topics like MIMO. We'll introduce massive MIMO, but we'll not study deeper into massive MIMO. We study deeper massive MIMO in 5G course, carrier aggregation, femtocells, home node B, CSFP, SRVCC, self-optimized networks, EMBMS, etc. So all these features in LTE advanced we'll be learning. So this is the entire second module for us. This is the entire second thing. So this entire second module is estimated to be taking around 50 to 54 sessions, estimated to be taking around that much time. So this is completely theory sessions. These 50 to 54 sessions are completely theory, where we would be learning LTE, advanced LTE, related protocols and how do they work, and we learn the protocols, we learn the test cases, we study the test cases, and we understand the meaning of the test cases, everything, all the theory part related to reading the test cases and studying the document specifications that are defined by 3GPP organization. All those activities we'll do in this second module time. Then we have the third module, which is going to take an estimated 12 to 15 sessions for learning voice over IP, SIP, and IMS. So here we'll introduce again various protocols, VoIP protocol, SIP, SDP, RTP, RTCP protocols, and MGCP protocol, Media Gateway Control Protocol. So we learn some protocols for required for the IMS, IP Multimedia Subsystem, which is where most of the jobs available right now in the IMS area. So we'll introduce all the IP multimedia subsystem network elements, just like LTE network elements, just like how we have introduced the network elements that are present in GSM. We'll start introducing IMS network elements, and we'll understand all the IMS call flows from end to end that are required to learn the things. So this is the Vivo IP, SIP, and IMS theory part. Again, on this we need to do the practicals. All right. Then where do we go to after these three modules? Then we have this fourth module called as LTE-IMS protocol testing practical module. I'll be explaining this practical module step by step in our next consecutive classes in the tomorrow, day after tomorrow classes. I'll be explaining that part. So I'm skipping this module for today, and because I have to take a lot of time to show all the tools required for protocol testing, etc., to show each and every tool, it takes time. We're going to spend the time in the coming classes. By the time we complete the demos, we'll be able to see this part. Now, the fifth module is about your how the project management will work, what kind of protocol testings, how many types of protocol testings would be there in the real working companies, and how these test cases will be managed, how the test code will be managed by using what tools, that part, etc. We will be learning it in this fifth one. This is generic project environment point of view. So you have to be aware before you go and join into a company, typically how the people in project work, how the people in a company work, and what do they do from morning to evening, and what are the different activities they will be performing, what kind of testing they will do, how they will do the testing, how they will raise the bug reports, complete process you need to understand. So this is completely process related sessions. The fifth module is testing methodologies and framework, complete process mechanism. Next, the last module that we are going to have in here is the OSI sessions, or we call it as a TCP/IP sessions. LTE is a all IP network. Entire LTE network works on IP technology. So having sound understanding on IP technology is very important to understand either LTE or advanced LTE or IMS, or for that matter 5G or IoT, Internet of Things. If you wanted to learn any of these technologies, the base is always going to be your OSI or your TCP/IP sessions. Now, there are going to be exactly 31 TCP/IP sessions you will have, in which we will be learning the TCP/IP protocol, starting from the OSI physical layer, data link layer, network layer, transport, session, presentation, and application layers, and by doing some practicals, 31 sessions. But these 31 sessions, I won't be taking live classes. These 31 classes will be provided to you in the video format from the moment that you have enrolled into this program. If you join into this training from tomorrow, you start getting these 31 videos from tomorrow, and you have to do the practicals by using these tools. How to use those tools and everything will be explained in that video lectures itself. In the old days, before um, 80th batch or so, we used to conduct even these classes before 80th batch. These 31 classes also we were conducting earlier. But what happened after 80th batch is a lot of advanced LTE topics started increasing, and when the interviewers are concentrating on advanced LTE topics, so we need to keep on increasing the advanced LTE subject part. So when the total combined course duration started increasing to 4 months, 4.5 months, 5 months, etc., so then we thought that we have to curb some part, and we decided to curb this OSI section. And what we have done is we have done a HD video recording for these sessions, and then we started providing these video lectures to the people who will be completing these classes in their free time whenever you have the time. But you have to complete these 31 video lectures for OSI before we start doing LTE practicals, because lot of things that you learn in these OSI classes will be directly be applicable in the LTE practicals. So you must complete these 31 sessions before we complete the first, second, and third modules. Before we start going into the fourth module, you must complete this 31 classes. So you will have like 2 months time available for completing these 31 classes. You can complete it in 30 days, you can complete it even in 10 days, or you can complete it maybe in 2 months. It's your own choice. When do you put effort, and how do you complete it? It's your own choice, but it is mandatory for everyone to complete these 31 sessions. So without these 31 sessions considered, our course is going to take 3.5 months, by just assuming that these 31 sessions are parallelly going in the video format. So if you get any doubts to in any one of these sessions, you will be able to contact me. Of course, once your group is formed, right now we have around like 25 people attending into this batch. Once the people decide and join, we'll be forming a WhatsApp group for these 20, 25 people who decide to join into this training. Now, once the group is formed, WhatsApp group is formed after these demo sessions are completed, you can start posting your questions into this WhatsApp group. This WhatsApp group will never get deleted. It will be there to support you both technical and non-technical purposes, to support you for the interviews, to support you for telling you where the job availabilities are there, and various other things. We use this WhatsApp group for regular day-to-day communication, and everything we use this WhatsApp group. We are even maintaining WhatsApp groups still from 2012 onwards, starting from batch number 31. We are still having the WhatsApp groups. We're proud to say we never remove these WhatsApp groups ever, because these WhatsApp groups started feeding our students a lot after some time. Because once these people started getting the job, still they will be in the WhatsApp group. Whenever they have an opportunity opening in their project or in their company, they started posting into these groups. So our HR people who are working on the background, so they will be taking the post from one group and they will be posting it into the latest groups who have completed the training, so that the other people will be able to apply for those jobs and try to attempt the interviews. So this way we are taking the help from the previous students who have got the jobs and working in the projects. By using their project requirements, we are recruiting the latest team, latest people from the batches. That's what we are doing. So if you get any doubts on these video lectures that you are attending, you can either contact me directly. You can actually post those questions on this WhatsApp group that we are going to create. So if others understand that question, they will come and they will answer it. If they don't understand the question, I will be there in the group. My number will be there in that WhatsApp group. I will be answering those questions. You can even directly contact me as well if you face any theory related problem or practical related issue related to these classes. But I guarantee you mostly that you will never face any kind of a doubt in my lectures. I can actually give you that much guarantee. Even if you face any kind of doubts, it will be minimalistic on the basis of my explanation. It will be minimalistic. So you will be able to smoothly function on your own and will be able to go through these lectures even though they are in the video format. Okay. So what module we have skipped is the fourth module. So we have five modules. This is the basic module, and we have LTE, advanced LTE, IMS module, and these are the project related and process related module. And then we have 31 video OSI sessions for learning the TCP/IP related concepts completely and doing the practicals related to that. Okay, so those are the video lectures. So because all this is theory part, I have nothing to explain other than just telling that every LTE protocol and every IMS protocol we will cover to the deepest level possible at the specification level. We'll directly be studying the specifications so that you will never fail in any interview anywhere. You can answer any question from anywhere. So we'll make sure that you will be becoming experts with these specifications, both on LTE part as well as the IMS part. And this fourth module, the practical part, what will be there in LTE-IMS practicals? How do we do the LTE practicals, by using what tools, etc. All the tools I'll start introducing from tomorrow's class. Tomorrow I will introduce some tools. Day after tomorrow I will introduce some tools. I will show you all those tools before you complete your demo lectures. So just hold on to that fourth module. That is actually the main module, the practical module. Remaining is all LTE, advanced LTE, VoIP, PIMS theory part. But this practical part is the major one that we'll actually concentrate on. So we come back to that in tomorrow's class and continue that part, discussing that part in our tomorrow session. So If you guys have any questions, anyone, you can ask me. Otherwise, I would quit the session here and we'll have the session continued at the same time tomorrow.
Any study document will be provided?
Yes, we do provide the complete study material from our side, from top to bottom. Everything we'll provide. You don't need to buy any book and all that. We'll send you all the material by making a mail group, just like how your WhatsApp group is made. We will be making a mail group as well. So on the mail group, you will be receiving all the material, starting from these basic sessions till the ending till the LTE part completely, the including the practical thing. Whatever we do in the classroom, you will be getting that material. Even the practical thing, whatever we do, you get that material immediately.
Thank you.
Nishant, yes, that is what I have already showed you. I hope you have missed it completely. In the LTE, advanced LTE, if you can see, we will be covering these radio protocols RLC, MAC, PDCP, RRC, NAS in the radio part, as well as diameter protocol, GTPU, GTPC, X2AP, S1AP, and MIPv4, PMIPv6, GRE protocols in the core part. So we will be testing, we'll be learning how to test all these protocols, both radio part as well as core part, as well as your IMS side. In IMS also we have diameter protocol used along with the SIP protocol. So we will be working with the diameter protocol on the IMS section as well, because diameter works both on the LTE core network side as well as the IMS network. Also we have diameter protocol present. So we'll be doing diameter protocol practicals in two places, at LTE level and at VoIP IMS level. We'll be covering both parts. So you have to say totally three things that we cover. First one is radio protocols. We will be teaching you how to test radio protocols. Two, how to test core protocols, core network protocols we'll be calling. Three, IMS protocols. So this is radio, this is service, this IMS is basically your multimedia services applications. All parts will cover. How that protocol testing will be done, by using what tools we do it, that part I have to still introduce. I told you that I'll introduce that in our coming up classes. Okay, I'll introduce that fourth module, the practical module. All right. Yes, practicals with all protocols. Yes.